Hello dear masters, I am Dean the Dorky Inkling, and today we're going to learn a bit more about numbers, okay? Now you're probably wondering what comes after 10. Well, let's see, shall we? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now each number is made up of digits that cycle through the same 10 numerical values from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 because it's base 10. Now, here's the thing. The digit on the right cycles through the whole lot before the one just to the left of it advances forward a bit, and so on and so forth. So continuing from there, 10 more than 20 is 30, then 40, then 50, 60, 70, 80, 90, 100, okay? 100. And you can do this as far as you like. If you add a fourth digit here, you get to 1,000. A fifth for 10,000, then 100,000, and finally 1 million. Although it's common parlance to add a comma after every 3 digits, just so you don't get lost. This is important a bit later. Now let's learn about advanced addition techniques, okay? So you have two big numbers, like 167 plus 51. So the first thing you do is add the digits on the furthest right. So 1 plus 7 is 8. Then move on to the digit further, just to this left, okay? So 5 plus 6 is 11. And we're going to put that one up here, add them two, and you get 218. Okay? Okay. Okay, now we're looking to advanced subtraction. So it's 207 minus 84. Again, we start on the digit on the far right. So 4. Okay, 7 take 4 is 3. And over here, we assume that's 10. 10 minus 8 is 2. So we cut that by 1. So, yeah, 123. Now let's move on to advanced multiplication, okay? The way this goes down is that we do two separate multiplication equations. One, a digit of the lower number here. Okay, so we'll start with 2 times 3 is 6 times 80 is 660. We'll put the 1 here. We carry the 1, okay? Times 100 is 200. Add the 1 for like here. Now for the tens, well, we add a 0 here, then start again. Then you add those two numbers together, and there's your answer. And now the part that everyone's been dreading, long division. So here's how it's going to go down, okay? You get the big number here, the dividend, divide by this small number here, the divisor. The first thing we're going to do is go from the highest digit from the left to the right. If that's not possible, then we try for a double digit. Now, how many times does 8 go into 63? As far as I know, that's 7. So that leaves a remainder of 7. How many times does 8 go into 74? Well, 9. What remains is 2. Now the remainder at the end is always less than the divisor. The answer we see here is the quotient. If you could make the remainder like so, you could have it as a 0.25 or 1/4, however you wish, really. And just a bit of a few symbols to work with. That's an equal sign. It means what's on the left is exactly the same as what's on the right. Now for inequality symbols, this means that whatever's on the left is more than what is on the right, like 5 more than 3. And this means that what's on the left is less or lower than what's on the right. So that's 2 less than 7. Okay? I think you get the idea. Now let's talk about roots. So that's basically the reverse of indexing. Okay? So the square root of 64 is 8. Okay? Now you could also write it as 64 to the power of a half. Okay? Whether in decimal form or fraction form. That's how it's going to go down, okay? Another thing to consider is that if the exponent is in the negatives, then 3 to the negative 1 becomes 1/3. You're essentially flipping it on its head, you know? Okay. Now the last thing we're going to look at is scientific notation. Now when you exponentiate 10, you have some interesting consequences. That exponent factor can tell you the number of zeros the answer will have. So the square of 10 is 100, which has 2 zeros in it. The cube of 10 is 1000, which has 3 zeros. Going by that logic, anything to the power of 1, 10 to the power of 1 would still be 10 because there's 1 zero in it. In fact, let this be a note to you. Anything to the power of 1 is always going to be the same as before. And here's a little interesting tidbit. 10 to the power of 0 is, well, 1, because there's no zeros. In fact, if you have anything to the power of 0, the answer will always be 1. Why is this important? Because we're going to look at scientific notation. Now, scientists are going to be working with numbers that are incredibly large. Okay? So, for example, this is 1,400,000. Okay? So how do I compress it into a form that a common person would understand? Well, count the digits first of all. There are 7 here. Take 1 from that is 6. The exponent for that 10 here. Then multiply it by, well, whatever the heck this thing is. So when doing scientific notation in your calculations, use this. It'll be a lot easier on your hands and your mind and any examiner's time and patience. Now this is all important because well, I shall save it for another video. Anyway, this has been Dean the Dorky Inkling signing out.